So guys, in our previous video we saw that whenever you are having a chemical equation is in this way, AA plus BB give rise to CC plus DD, where your A, B, C and D represents your stoichiometric coefficients. From the rate law we can write the rate expression as your rate is equals to the rate constant into concentration of A to the power of X into concentration of the B to the power of Y. And of course I have mentioned that your X and Y can be equals to A and B or cannot be also equals to A and B. Why I am saying so? Because whatever this X and Y is there, it is not a theoretical calculation. So they are only obtained through your experimental values. Of course we came to know, of course, A and B are stoichiometric coefficient. Then what is this X and Y? So that X and Y will be now learned in this video under the concept called as order of a reaction. So basically this X and Y is called as an order of a reaction. Then what does this order represents? If you are taking the sum of these exponents as X plus Y, it represents the overall order of a reaction. If you take it as an individual, what is X and what is Y, then X and Y represents the order with respect to the A, that there is a reactant A and B respectively. Let us have some detailed analysis of it. Of course the problem we have solved, I have taken the same thing over here. So what you are having here, you are having as 2 and here as 2 if you balance it. Of course we came to know from the rate expression and through the experimental conditions that our rate is equals to K times of NO to the power of 2 and O2 to the power of 1. Then what is the overall order of this reaction? Remember, the overall order of a reaction is X plus Y, that is 2 plus 1, that is equals to 3. That means what? The oxidation of your nitric oxide is a third order reaction. Able to understand? So it is representing an overall order of a reaction. Then what does this 2 represents? Of course, it is an individual order which is going to represent. It is, if I say order of the reaction of NO is 2 means what? Our NO follows an order of 2, whereas our O2 follows an order of 1. Or in simple word, your NO is following a second order reaction, whereas your oxygen is following a first order reaction. Very much important. So depending upon this order, we are going to see mainly a zero order reaction. Zero order reaction. That means what? A rate you will be writing, of course, which will be equals to that of only the value of K. Of course the concentration will be there, but what would be happening? Their raised exponentials will be 0. So what happens? 0 plus 0 will be equals to 0. So overall order of the reaction will be zero order reaction. Can you give me an example if you ask me? Of course I can. If I take the formation of an ammonia, N2 plus 3H2 give rise to 2NH3. So basically what I say when you are taking this, it is taking place on your platinum catalyst. True? That means what happens, remember, whenever a reaction is taking place on the surface of the catalyst, you have to keep in your mind all such reactions will be following a zero order reaction. That means what? Whatever the rate will be there, they will be independent of the concentration, whereas they will be dependent upon the surface area of the catalyst. Why I am saying so means, of course a detailed part will be seen in your surface chemistry. Now just we'll see a hint. So of course when I am taking a platinum surface, what we say is whenever you use a catalyst, the rate of the reaction increases. How it is increasing? Because whatever the catalyst you are using, they are providing a means or they are providing a medium for the reaction to occur. That means what? It is allowing your N2 and 3H2 to come and sit on it. And when they come and sit, they are reacting. So by this way, the rate of the reaction increases by the help of a catalyst. But what happens on increasing the pressure? Whatever may be the concentration of your N2 and 3H2, the sitting part of your N2 and H2 depends upon the surface area of the catalyst. True. Even though if the surface area is less and the concentration is more, what happens? Catalyst will only have the capability to adsorb. I'm using the word over here as adsorb the reactants only limited to its surface area. And so what happens? So whatever the rate will be obtaining, that is how fast the reaction is progressing, will be only dependent upon the catalyst surface and not on the concentration. So that gives you what? The rate will be independent of the concentration of the reaction, whereas the rate will be dependent on that of your surface area of the catalyst. So you have to keep in your mind that whenever a reaction, majorly, whenever a reaction is taking place on the presence of a catalyst, such reactions follows a zero order reaction. Similarly, you can also say that, for example, the thermal decomposition of your HI. Okay, the thermal decomposition of your HI on the surface of gold to give you as H2 plus I2. Yes, is another order, which is another example of your zero order reaction, because whenever you use a catalyst, such rate depends upon the catalyst surface, that how much amount it can accommodate on its surface, neither what is the concentration. So what happens over there? Our rate will be independent of the concentration of the reactants. So that will be the reason we will be calling it as a zero order reaction. So if I want to write for this one, how I am going to write it? Of course, rate will be equals to K times. Yes, of course I would be writing my N2, but what would be happening? It will be having a zero order. Similarly to that of your H2, it will be also having a zero order reaction. So what happens? Anything to the power of 0, we know it is equals to 1. So rate will be equals to K. So such reactions is called as what? Zero order reaction. Or in simple words, we can say that the rate of a reaction is independent of the concentration of your reactants. And the major example you can also give as decomposition of ammonia. Yes, on the presence of your platinum catalyst. Is that okay? Coming to the other part, which is called as a first order reaction. First order reaction. So here what you can say, yes, the rate of a reaction is proportional to the first power of the molar concentration of your reactants. That means what? If I choose to write its rate expression, then rate will be equals to K times of the reactant, which will be raised to the power of 1. So this will be called as what? As a first order reaction. You have to keep this one in your mind, guys. So first order reaction means what? Is the rate of a reaction will be proportional to the first power, alva, first power of the molar concentration of your reactants. Example what you could give? Of course it will be your decomposition of PCl5. Decomposition of PCl5 to give you as PCl3 plus Cl2. So when you are taking as a decomposition of PCl5, what happens? You will be getting as what? PCl3 plus Cl2. So in this case, what is happening? Whatever our rate is there, that is mainly depend upon just the concentration of your PCl5. As the PCl5 is increased by 2 times, what happens to the rate? Rate also increases by 2 times. Since why? It is to the power of 1. Can you please define for a second order reaction then? Of course, what you could say, the rate of a reaction is proportional to the second power of the molar concentration of your reactants. So these are the things you should keep in your mind. So what do you mean by now order of a reaction? Order is actually calculated through your experimental part. That should be remained in your mind. But you have to, by the way, also remember that the x plus y, the sum of the exponents x plus y represents the overall order of a reaction, where x and y represents the order with respect to A and B respectively. Or in simple words, if I have to say, how can I say? Sum of the powers, okay? sum of the powers of the concentration terms of the reactants in the rate expression. Alva? Sum of the powers, yes, of the concentration of the reactants in the rate expression or a rate law expression is called as what? Order of a reaction. So in this order of a reaction, we have understood what do you mean by a zero order reaction and what do you mean by a first order reaction. Just let me give you an exercise now. Now let us take some exercise problem. So you have been given with rate is equals to K times, okay, of A to the power of 1 by 2 and B to the power of 3 by 2. You can please notice over here, your order of a reaction can be even fraction. It can be also equals to 0 and it is an experimentally determined value. So they have asked you to calculate the overall order of a reaction. So how will you do overall order? Of course, if you are considering this one as your X, this one as your Y, then X plus Y gives us the overall order of a reaction. So what will be the answer? 1 by 2 plus 3 by 2. Yes. So what will be? It is equals to 2. So this means what? Whatever, for example, A plus B was giving you C plus D. I have done it experimentally and I calculated the values of X and Y. So what it represents with respect to A, it is a half order reaction. With respect to B, it is 3 by 2 the order of the reaction. But when I consider the overall reaction, what is the order? It is a second order reaction. So that is the very much important for us. So overall order means what? When you are considering the whole reaction, what is the order? Okay. If I just consider the X, it will be only limited to that particular reactant. Okay. Let us take now one more example. So rate is equals to K times of A to the power of 3 by 2 and into B to the power of minus 1. What will be the overall order of a reaction? Yes. So 3 by 2 plus of minus 1, that is equals to 1 by 2. So please remember that if I consider the same reaction with respect to this, what is happening? The overall order of a reaction is half. Able to understand, guys, what I am writing? So overall order of the reaction will be half. So this is called as what? As an order of a reaction. So how do you define it? It is the sum of the powers of the concentration of the reactants in the rate law expression. Okay, is called as order of a reaction. This order of a reaction can be 0, can be negative, and also it can be a fraction. You have to keep in your mind, it is an experimentally determined value. Very much important, because whatever the order you will be going to get, that represents how fast the rate will be changing, because it is rise to the certain reactant terms. So if it changes, we come to know that how does your rate also changes. For example, if I write it as rate is equals to K times of A to the power of square, that means what? It is a second order reaction. Able to understand? So this is very much important to know that what do you mean by order of a reaction. Now what is the main use of this order of a reaction? Let us see. Basically, when we are saying as a rate constant, remember, of course it is also having a unit, but its a unit is dependent upon this order of a reaction. Why is it? Let us see. Of course, when we say the rate constant, how can I write it? K is equals to, it is given as concentration to the power of 1 minus n divided by time. That means what? Here n represents your order of a reaction. Order of a reaction. So this is a general expression which represents the unit of your rate constant. So basically we know that concentration is having the unit as what? Mole per liter. Alva, only for the concentration part I am asking. Mole per liter divided by second. Remember, 1 minus n is only for that of your concentration term. Okay. Now when I say what will be the unit of the rate constant when the order of the reaction is 1, of course it is, okay, let us take with 0 first. N is equals to 0. So what happens? Mole per liter to the power of 1 minus 0 divided by second. Yes. So nothing must going to change. 1 minus 0 is 1 itself. So you'll be getting as the same mole per liter per second. But what if I choose n is equals to 1? So mole per liter 1 minus 1 divided by second. So 1 minus 1 means 0. Anything to the power of 0 means 1. So what is left out? Only per second. Remember, see, with respect to the order of the reaction, our rate constant's unit also goes on changes. So if you are remembering this formula, concentration to the power of 1 minus n by time, easily we can determine that what will be the unit of your rate constant. Very much important. Certain times they will not be giving you the order, they will be just giving you the value of your rate constant with respect to the specific unit. So if you just see the unit, it should come to in your mind that what will be the order of the reaction. Same case if I take as n is equals to 2, that is your second order reaction. Can you please help me? Of course, mole per liter. What I should write here? First comes 1, yes, minus n, alva 2 divided by second. So 1 minus 2 means what? Mole per liter to the power of minus 1 by second. So how can I write? Of course, I have said on the in my previous example, 2 into 2 to the power of square means this square is applicable for this 2 and also for this 2. So here also mole is there, per liter is also there. So mole inverse, yes, mole inverse. Then next what will be happening? Minus into minus plus, 1 into 1, 1. So it will become liter. Can you make the difference? Per mole, liter per second. Able to understand, guys? So this will be the unit of your rate constant when the order of the reaction is 2. Very much important. So we have in this video, we have come to know that whatever the x and y we were obtaining in our rate expression, that was mainly called as an order of a reaction. Then how will you define this order of a reaction? It is the sum of the, yes, it is the sum of the powers of the concentration of the reactants in the rate law expression. Alva is called as what? Order of a reaction. So overall order ne yav tara calculate martira, just you have to add those x plus y. What does your x indicates? It is representing a respective order of that particular reactant. Y also the respective order of that particular reactant. So we came to know in respect to the order, we are mainly studying zero order reaction, and we came to know that in a zero order reaction, the rate of a reaction is independent of the concentration of your reactants. And examples, we saw that any reaction which is taking place with the help of a catalyst, alva, they mainly follows that of your zero order reaction. And in the case of the first order reaction, what we saw, of course, the rate of the reaction is proportional to the first power of the molar concentration of your reactant. Please mark my words, first power of the molar concentration of your reactants. And examples we saw, it's a decomposition of your PCl5. Yes, so this was giving you the general knowledge of that of your what do you mean by an order of a reaction. In the chemical kinetics, this order of a reaction is very much important. As we have seen when we are solving the problems, how does this x and y, by taking its experimental values, we were able to determine what would be the change in the rate of a reaction. Alva. So it is very much sensitive part. If x and y changes, of course the rate also keeps on changing. And you have to keep in your mind this order of a reaction can be negative, can be zero, and can be even a fraction. Yes. And also you have to keep in your mind that it is an experimentally determined value. Theoretical wise, we cannot obtain the values or cannot obtain the order of a reaction. Then with the help of an order of a reaction, we also saw that how to determine the unit of a rate constant. So unit of a rate constant ಗೆ ಯಾವ ತರ ಹೇಳ್ತೀರಾ? First you have to remember the general formula, concentration to the power of 1 minus n divided by time. So of course we know what concentration is, what mole per liter alva, divided by time andre second. So what does this n represents? Remember, don't get confused with n minus 1. It is 1 minus n. First barad 1 alva, you have to keep that one in your mind. 1 minus n. So that n represents your order of the reaction. So if they give you the particular order of a reaction, your rate constant also goes on changing. In the problems, they can ask you directly by giving the value of k with respect to the suitable units, so that you should have the ability to predict what will be the order of the reaction. Is that okay? So let me give you a question. Of course, when I said as an acid hydrolysis of an ester, alva, CH3, COO, C2H5, in the presence of water, it was giving you as what? CH3, yes, COOH plus C2H5OH. So when I was writing its when I was writing its rate expression, how did I write it? Rate is equals to K times of the molar concentration of what? CH3COO C2H5 to the power of 1, whereas H2O to the power of 0. Can you please say me, in the acid hydrolysis of the ester, what is the overall order of a reaction? Of course, it is overall order of a reaction is how much? 1 plus 0, that is equals to 1. So acid hydrolysis of an ester follows a first order reaction. Then what does the value of this H2O represents? Whatever may be the concentration of your reactant, our rate does not depends upon it. Able to understand what I am saying? So our rate expression, that how much fast or what is the velocity of your reaction, is only determined by the concentration of your ethyl acetate, and it is independent of the concentration of your H2O. Why I am saying this? Because if you are going to increase the concentration of your ethyl acetate, of course your rate also goes on increases. But in case if you are increasing or decreasing the concentration of your water, there will be no effect on your rate. So this is a major thing which an order says, that how does your rate depends on reactants. Okay, so in our next part we are going to see what do you mean by molecularity of a reaction. A very important concept, and by utilizing our order and molecularity, we will be defining a new order of a reaction which will be called as pseudo first order reaction. So in our next video, we will be looking after